Welcome to the video on Chapter 3, Perpendicular Lines. This is the final lesson for this chapter on angles. We're going to answer the question, how can you make two lines perpendicular? Perpendicular lines create pairs of congruent, adjacent, and supplementary angles. We use symbols to represent things in math, and so the symbol for perpendicular lines look like this, and this is how we would write it. Now we read this symbol as perpendicular to, so we would say line AD is perpendicular to line BC. That's how we would read this math symbol statement over here. Using this symbol for perpendicular lines, line AD is perpendicular to line BC. And this is the diagram that is created whenever you actually draw out line AD being perpendicular to BC. So AD is right here, BC is here. Being perpendicular means that they cross at a 90-degree angle. I know that it has to be 90 degrees because in order to be adjacent, which means next to each other, and congruent and supplementary. So congruent and supplementary means that they have to add to equal to 180 degrees, but congruent means that they have to be the same measure. So in order to do that, they have to be 90 degrees. So in order to satisfy the three things that make lines perpendicular, being congruent, adjacent, and supplementary causes the angles to create 90 degrees. So if we look at this example here, it says given the below diagram, AD is perpendicular to BC. That should say BC here. So it's perpendicular to, so it's not labeled in the diagram, so I'm going to go ahead and do that they are perpendicular, which means that these are 90 degrees. And you don't have to label every single corner here 90 because then you're just going to create a big box. But if one of them is 90, then they all have to be 90. That's just from vertical angles, it's from linear pairs, it's from all of that stuff. So if one of them is 90 degrees, they're all 90, ignoring this EF ray, of course. Now, speaking of the EF ray, this is asking us to look at angle BEF and FEC. So angle BEF and FEC, well, they're creating a line. So they are a linear pair and supplementary, which, remember, does add to equal 180 degrees. Now, as we move into this next relationship, we want to make sure that we change this to FEC because we're still comparing angle FEC here. This time we're comparing it with angle AEF. So AEF and FEC, because they are next to each other, they are considered adjacent, but they are also adding to equal 90 degrees because they're creating this right angle right here. So AEF and FEC are adjacent and complementary. So in this example, we are given that KG is perpendicular to CA, so KG is perpendicular to CA, so I'm going to go ahead and come in here and draw a right angle so I know that they are perpendicular. And then it also says the measure of angle CRT is 38 degrees, so I'm going to add that right down there. So if we look at our questions here, they're all asking for the measures of these angles, so please keep in mind that we are going to be answering in degrees. So if we look at angle TRK, well, TRK is it's adjacent to, but it's the pair with the complementary angle. So I'm going to take 90 and I'm going to subtract 38 to figure out this missing angle. So that's 52 degrees. For angle GRA, well, GRA is just one of these right angles in here. So I'm going to label that with another box there just to answer this question, 90 degrees. And I'm using the color coding so you can kind of see along how we're answering each problem as we go. So measure of ART, so ART, so that's going to be the 90 that's here plus the 52 that's there using the angle addition postulate. So that's 142 degrees. And the last one, TRG, well, that's going to be this 90 degrees plus the 38 using the angle addition postulate for these two angles. So that is 128 degrees. So now I want you to go ahead and think about these questions here, and I already answered this one earlier. What kind of angles are congruent and supplementary? So think about what it means to be congruent and supplementary. I'd focus on the starting point of supplementary, remembering that congruent means that they have to have the same measure. And now this one we've not discussed yet, but it doesn't say what kind of angles. It's what two angles are congruent and complementary. So kind of using that same mentality, see what you can come up with for complementary and congruent. And the correct answers are right angles, so that's the kind of angles that are supplementary and congruent, but the two angles that are congruent and complementary would be two 45-degree angles. Last example here, it says given the diagram below, which looks like we do have, though it may look a little silly, it does look like we have a right angle in here. It says the measure of angle 1 is 6x, so I'm going to label that, and the measure of angle 2 is 4x plus 10. And our job is to find the measure of each angle. So there's 3 angles in here. Based on the diagram with that square there, I can say that that is 90 degrees, which is going to be helpful to find x and those missing 2 angles there. And I'm just going to use the angle addition postulate, which says if I add 6x plus 90 plus 4x plus 10, that's going to equal 180 degrees because they are creating this line here. Solving for x, I got 8, so now I'm going to plug that back in to my expressions here and actually find the values of those angles. So plugging in 8 for my x values, I got the measure of angle 1 to be 48 degrees and the measure of angle 2 to be 42 degrees. I want to conclude this lesson by bringing us back to the lesson essential question about how can you make 2 lines perpendicular. The answer would be to make them 90 degrees because that is the only way to have congruent, adjacent, and supplementary angles at the same time. That's the definition of perpendicular, but in order to do that, they all have to be 90 degrees.